Hello, hello.
Hello.
Hello there.
Oh my gosh.
I'm listening right now.
Am I dreaming? Am I dreaming?
No.
I'm really talking to Liz Fong Jones. The amazing
right
Liz
now.
Fong Jones. Is that it?
I've been a
live on
huge fan
camera.
since your KubeCon 2019 talk, so this is great. I'm very excited for this, but
Oh, wow.
I think we'll give you a moment to introduce yourself first before we're just like, forever. Do you want to talk a little bit about who you are and what you do for the audience?
Yeah.
Sure. I'm Liz Fong Jones. I'm a principal developer advocate at Honeycomb, and I'm also a outgoing member of the Open Telemetry Governance Committee. So I'm happy to talk all things observability, site reliability engineering, large-scale systems. How do you build and run them, and how do you make them fast?
Yes, absolutely.
We're so excited.
And before we actually jump into all the interrogation questions for you, Liz, because you're amazing, we want to hear from you. How are you, my friend? Like in a personal level. Tell us.
Things have
how's
been
your
a
days
chaotic
going?
whirlwind, but I am settling back into my day job. It's been good. I have a lot of exciting stuff coming down the pipeline. I'm working on a lot of really, really great stuff.
That's so cool, right? We were looking forward to hear all about it because everything you do is so amazing. Like, I'm a fan, Liz. Okay, I can't deny it, so that's why I'm so excited.
Thank you.
We're
Yeah, you're
excited.
clearly gushing. you're fangirling
I
a
know
little.
we're excited, but actually so is chat. So I'm just
Yeah.
going to throw some of these on here. Chat's very excited. We've got full caps Liz.
Yes.
You didn't say royalty would be here.
Yep.
Liz with like 6 exclamation marks. Listen up, Liz is incredibly awesome.
Yep.
You're
And I'm
flattering
not
me. Come on,
paid in tacos
let's
to say this.
I've only heard truth so far. I've only heard some truth. Yeah.
We've got everyone stay calm. Basically, chat, I actually didn't even highlight all of them. There's more. But we're very excited to kind of be here and have you joining us on the show today and have this session.
All right. So, Liz, the reason why we brought Liz here is because, again, that she's amazing, it's like a consensus, right? But she also has lots of experience with like SRE, observability, like you name it, hands-on experience, knowledge experience, consecutive experience. And we brought her here today to help us understand, or better yet, to put together everything that we've discussed here today regarding observability. Because so far, if you recall the agenda, we have like discussed different topics, like in no specific order: open telemetry, eBPF, metrics, Prometheus, and all of that. So, Liz, could you actually put all of this together in the best way possible so we can, like, for everybody that never heard about observability, what's your thoughts on this? Let's start with the basics. Like, what's observability for Liz Fong Jones?
So to me, observability is about how we can understand and debug our systems and being in conversation with our systems so that we can answer questions about what happens, regardless of whether it's something we've seen before or whether it's something that's brand new. So where projects like OpenTelemetry come in, where signals like metrics or logs or tracing come in, right? Like they're kind of the sources of the data. But we also have to think about how do we prepare ourselves as a team to work with this data to be able to answer those questions. So it's not just about, what kinds of telemetry am I collecting? It's also about how can I analyze it and how can I get answers quickly so that I can get my systems working, or so I can understand what my systems are doing so that I can make them work even better. So that's basically kind of tying all the pieces together, right? Like you've heard so far about all of the various technical components. What I want to show you today is a little bit about how you might make a system, how you might benefit from observability in your systems and kind of being able to debug performance problems.
Amazing. Yeah. I told you. She's the perfect person to put all of this complexity together in a cohesive and simple way to understand. Like, okay, good. So let's then jump to a question that I've heard. I actually got a nice t-shirt from Honeycomb once. Do you know that?
Mm-hmm.
And that t-shirt says, I test in production. So, Liz, how observability help us to test things in production?
So when we say test in production, we don't mean don't do any testing before production. What we're saying is that there's a diminishing return to being able to kind of try to reproduce production in staging and trying to kind of make production or make staging as big as possible and sophisticated as possible. The argument that I make is everyone tests in production, whether they like it or not. The question is just how good are you at it? So when we talk about being able to test in production, what we mean is being able to understand, to be able to run experiments and analyze results in production without having to kind of try to get that exact same setup going in some other separate environment. Because real problems are going to always happen in production that you have not encountered in staging before, or else you wouldn't have released it in the first place.
That's perfect. Yeah, and since you've mentioned this, I remember one of your presentations where you said something that it really stuck in my head, which was, all right, when you develop a code, when you kind of build your container images and all of that, you are testing in an environment where it's not look like the production environment, like a lots of like a kernel versions, software patches, the network bandwidth, everything's going to be different from where you test the code. So I think that's what you're saying, right? Like the ability to test things that wouldn't be foreseen, right? And during the
without being
time,
foreseen,
right?
And even better yet, why should you have to, right? Like, sure, I can push rapid fire to production, and I can like almost do the metaphorical equivalent of monkey patching the code live in prod, right? Like, but wouldn't it be better if I could analyze the results instead without having to touch the code? That's better in a lot of ways, both from a production stability perspective as well as a compliance perspective, right? That, sure, you as a developer may not be allowed to mutate production, but you don't have to mutate production in order to understand it, as long as you have the right ability to analyze the data that's coming out of it.
Nice. Jackie, do you know if we have any questions in the chat? Because I can't see it from here. Maybe you have a better view from here where I am.
So far, we don't have any questions in chat. Just a lot of people very excited that the session's happening.
Yeah.
But
as someone said, misinterpreted. It's not monkey patching or monkey poxing. It's monkey patching.
Okay. Oh, that's important.
Oh my gosh.
Okay.
But yeah, chat. If you do have questions, throw them in chat so that we can ask. And I believe, Liz, you did say there was something you wanted to show, right?
Yeah, I wanted to show you a quick live demo of how easy it is to use OpenTelemetry to get data flowing into an observability tool.
There we go.
So
I
what I'm going to do
screen.
is I'm just going to take this application here. So this application here is a demo application that you'll notice as it runs longer and longer, it gets slower and slower. So we might want to understand why. Why is it behaving so slow? So what I'm going to do is I'm going to remix this project. So I'm just going to clone a copy of it that I can edit. And I'm also in parallel going to come over here into Honeycomb. And I'm going to open up a switch teams to, let's switch to one of my sandboxes. And I'm going to create a new environment. And that's going to give me a API key. So I'm just going to take this API key. Don't worry about it being shown on screen. It's fine. I'll delete it afterwards. So let's see whether Glitch has woken up and decided to give me a new workspace. Oh, hey, maybe it needs me to actually log in first, and then it will do that. This is one of the fun little things. Okay, so now hopefully will you let me create a copy? That's not very happy today. That's okay. So I'll just go ahead and go in here, and I'll just talking about testing in production, right? Like, let's go ahead and open this up and see whether Glitch wants to cooperate with me today. Okay, Glitch does not want to cooperate with me. That's fine.
That's totally fine.
It's okay. I'm a site reliability engineer. I brought a backup.
Yes, I love it.
That's the mantra of site reliability engineers. They always are well prepared.
Yep. Okay, so I brought a backup. If Glitch is not working, I'll open it in getpod. That's fine. So I'm just going to fork this repo, and I'm going to get a separate copy of it. And what I'm going to do is over here, you can see that I have, I've got a application here, right? This is what is calculating, what is calculating those numbers. And I've also got a file that's already set up with OpenTelemetry that basically contains, hey, by the way, automatically instrument the Express web server, or hey, automatically instrument all outgoing HTTP requests. And what I'm going to do is I'm going to take this and I'm going to rename it to just throw in my Honeycomb API key. Let me just make sure that that's correct. Yep, that looks correct. And now what's going to happen is OpenTelemetry will automatically spin up. So I should be able to come over here. Under ports, I think there's an option to open the port explorer somewhere, I think. Ports. Oh, they moved my cheese. Okay, so here's the sequence of numbers app. And as we can see, it is starting to get slow. So now I'm going to come over here and I should have data coming through now. If not, I will just really quickly, unauthenticated and known API key, check your credentials. All right, well, that's easy enough. Let's just make sure that that file has saved and been updated. That looks like that's been saved. So I'm just going to run it again. Hit go and then stop. Still unauthenticated. Interesting. So that's okay. What I'm going to do is I'm just going to source.env just to get that exp into the environment if it wasn't already there. If I were on glitch, it would have automatically done that for me, but that's okay. Maybe I need to run that manual step. Okay, now it's not saying unauthenticated. So it says data received. Click here to explore your data. See, that was pretty easy, right?
Yay!
So now I can see that there's something that says, sequence of numbers here. And if I ask it for the data from the past 2 hours, then I should be able to see that I've gotten 4 requests traced so far. Let's look at an example of one of those traces. So over here, we can see that a request was issued to the Fibonacci endpoint. This is computing the Fibonacci sequence. So I'm just going to collapse all the spans so that you can see, yep, it is computing the sum of the previous 2 numbers. And from there, it's computing the sum of the previous 2 numbers. And from there, it's computing the sum of the previous 2 numbers, and so on, and so on, and so forth. So yes, that is what is happening when we are computing this series. So I'm going to set this to automatic mode so that it just repeatedly runs and generates me a little bit of data. And I'm going to come into here and I'm going to start asking some more interesting questions, like show me a heat map of the duration. So now I can start to see, let's maybe zoom in on this part of the graph. So now I can start to see, yep, fast, 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 slow, fast, slow, fast, fast, slow, right? Like it's doing that. But the cool thing is I should be able to ask questions like, hey, what's going on with, what properties do the slow requests have in common? So if I just draw a box around this, right, like this is, I think, part of what is cool about any kind of more innovative observability suite is that it lets you kind of poke at outliers and anomalies, right? So I can ask, hey, what are the fast versus slow URLs sharing in common, right? So the fast URLs are all index 0, 1, 2, 3, 4, 5, 6, but when you get to 7, 8, 9, 10, it gets real slow. That's really interesting, isn't it?
Yep.
Right? So that kind of lets you get an idea that, hey, maybe the URL is important, so maybe let's group by that field. And now this has run for a fair little bit. Let's look at the past 10 minutes. So now I can actually ask questions like, hey, what's going on with the 99th percentile latency broken down by URL? Right? So we can start to see patterns like the latency sure does increase by roughly a factor of, I don't know. Let's, instead of ordering by count, let's order by the URL ascending. Okay, well, we'll fix this in a second. The fact that it says, 0, 1, 10, 11, 12, 13, 14, that's a little annoying, right? But we can see that it's roughly increasing by a factor of a time and a half. every time that it increases, right?
Like exponentially, right?
Yeah, it's almost exponential, isn't it? So I think that this is kind of an interesting approach to thinking about the performance problem here that we're seeing, and also being able to tie that to specific requests and being able to investigate and figure out, is there any pattern here? What's calling what? It turns out that this is a demonstration that we used in our workshops at Honeycomb to demonstrate open telemetry, because this is a microservice in the box. You actually only have to instrument one service. And after that, it'll kind of call itself, kind of simulating various layers of your stack talking to each other. So now let's fix that problem that I mentioned where, hey, like it's really, really annoying to have to work with the URL field, right? And trying to extract this individual number. So this is kind of where I talk about being in conversation with your code, right? Like if I start annotating my code, with metadata like, hey, I want to keep track of what the current parameter that I was called with is, I can do that. And that will kind of annotate and decorate all of the subsequent trace bands that we've created in order to make them queryable. So I'm going to stop it and start it again. And now I'm going to set this back to auto mode. So now, if I go back over here, starting to run again, but I should be able to group by, in addition to URL, what did we call this? We called this parameter.index. It's not created yet. Let's try that again. So, set it running, set it to automatic mode. Okay. And now let's run that. So, I wonder why this is not picking up that code that I just added. We'll give it a moment to catch up. Oh, parameter.index is a field in the dataset now. Okay, great. I see. So maybe I need to refresh this. There we go.
Yep.
Cool. Okay, so now we can see that I have automatically had extracted to me, at least for the newer calls, this value here. So now I can check that parameter.index exists, and I can sort instead of by the URL ascending. Let's sort by the index ascending. Hey, look at that. Now we can actually see it increasing smoothly from 0 to 13. And I could even plot, in addition, the index as a number itself, right? See it going up and up as we go forward through time. So that's kind of what we mean when we talk about observability empowering you to do kind of more than you could do with metrics or logs alone. Because metrics would never let you kind of dynamically slice and dice this on the fly.
Yep.
You would have to have predefined a metric for this particular thing. And heaven forbid that you need to group by multiple different things at the same time, right? Like, let's suppose that I also wanted to group by the port number or group by the user agent or something like that, right? Like, I wouldn't be able to do this if this were a metric system. So that's kind of a little bit of a taste with a digestible example. But now let's go ahead and turn our attention to something a little bit more sophisticated. I want to show you actually what it looked like from Honeycomb's perspective as I was working with this data. Because, of course, Inception, we have to go deeper.
Yep, that's
love
definitely. And by the way, are you telling us that you're going to be even more sophisticated than this? I mean, come on, you're mind-blowing already, so it's exciting.
Yeah. So I'm going to look for root spans where the app.user.email is lizf@honeycomb.io. And you can see, I just started working with the production UI right there. Let's group by URL to see what I was doing. Nope, URL's not the right thing, but that's okay. It's request.url. Cool. So you can indeed see here that I am working in the AWS Live environment, and you can see that I've run a bunch of queries.
Yep.
So let's specifically analyze the performance, right? Like you saw earlier where that request spun, right? When I was running it and it was like, help, it's stuck. Let's figure out what happened there. So I'm going to show heat map of duration. let's look at this real live example. Oh, hey, look, that request took 15 seconds right there. Boom.
Wow.
Let's drill down into it and figure out what went wrong. Okay, so that was a WebSocket for running a query. And yep, that looks like on our backend, that got really slow. That request actually took 15 seconds to execute on our backend. Mm-hmm. So I'm just going to go ahead and grab the trace ID to look up in a parallel system. So new query in the retriever traces dataset, and count where trace.traceID equals that. And I should see exactly one trace. Or, well, I might see multiple different spans corresponding to that trace. Yep, so there's 179 spans corresponding to that trace, but let's go ahead and pop that open in the trace view, and let's have a look at the Honeycomb query backend and see what it did. Mm-hmm. Oh, thank you, Taco Dog. Would you mind featuring that comment from Taco Dog about loving Honeycomb?
Yes, definitely.
There it is. Oh, I think we both did it at the same time.
I love Honeycomb so much. I recommend clients to look at it, and I don't even get to pay to say that. When something is so cool, you don't have to be paid to say this. Just be honest.
Okay, so what happened here? It looks like one of these requests. Oh no, I see that. Oh goodness. This is a mutex. So a single mutex got held, causing me to lock up for 13.5 seconds. That's why that request was so slow, right?
Oh,
so
okay.
I was able to, right, like starting from the high level picture of one user writes in, me, writes in with a complaint saying, help, Honeycomb is slow. I was able to identify exactly what call contributed to that being super slow. The other interesting thing is I can actually see on the sidebar on the right-hand side that it's not just me having this problem, though, that loads of people were having that problem right then at 13:15. And loads of people were having problems with that an hour before at 12:15. And I bet if I go back 24 hours, I bet what I'm going to see, right, again, this is for the try read lock. Yeah, every hour on the hour. So I got really unlucky with when I happened to run that, such that I ran into this problem. I swear, by the way, this was unscripted. I did not know what was going to happen, but this is a fun and interesting investigation.
We trust you, Liz. That's
and I need to now go back to my team and say, like, hey, WTF is going on, right? So anyways, I can look at that. And then the other cool thing is I can potentially, let's load that trace back up again. I can potentially try to validate, where is the blocker, right? Like, what's happening? The other fun thing about this pattern here, by the way, if you see that little diagonal line, we call that the kind of shark fins of doom. It's the pattern that happens when you have... Why is this not loading? Refresh. There we go. It's the pattern that happens when the world stops for a certain amount of time and then requests finish all at once. So that the oldest requests take the longest time, and then the time decreases linearly from there down to 0, right? Because the most recent requests that were queued for 100 milliseconds, those will say I took 100 milliseconds to run. The ones that were blocked for 2 seconds will say I was blocked for 2 seconds, and my duration is 2 seconds, right? So I think that this is kind of a really cool example, right? Like this kind of gives us an idea about the performance, and I can also validate this really quickly, right? This query ran entirely locally. All the services say retriever traces. So I can actually ask for a, please work. No, I think this is not working today. That's rather unfortunate. So normally I'd be able to get a quick preview. This is actually work that's in beta that I'm working on right now to be able to examine the CPU time spent locally. To be able to see how long did this individual process spend working on this, as opposed to all of the waiting on I/O or waiting on something else. But there's another thing that we can do here. So this is kind of a complement to Honeycomb's observability. So I can now go into, I'm going to go into retriever traces, and let's go to block duration, and let's tag the reader, and let's tag environment is production for the past hour. So I'm going to load that up and see what it does.
So just a quick question, Alyssa. What you're showing right now is kind of a part of the Honeycomb platform, or is kind of something?
This is actually our friends at Pyroscope. We happen to like Pyroscope because it kind of gives you interesting perspective on what's happening.
Nice.
Yeah. So interestingly, so this shows that there was a small spike in blocking here. Wonder why it's not reflected here, right? Because this should show up under. Should show up somewhere in here. So I'll have to actually go to our source code and see what is this read lock. Try rlock. So let's go here. Let's see what's in this trace span. So try rlock is called from this function is called getDataSetVersion. Okay, so if I go ahead and go to where was I? So if the hypothesis is correct that getDataSetVersion is slow, we should be able to see that. Once this loads, we should be able to see that reported here. getDataSetVersion. Wonder why that's not coming up as one of the mutex. There we go. I was looking at the wrong thing. I was looking at blocking on IO, not blocking on mutexes.
Oh, gotcha.
Okay, so let's try that again. So let's execute this query. Uh-oh, it seems to have logged me out. What's going on? Okay, now that's working again. Okay, so now if I type in mutex duration. So this is kind of, right, like we've just to recap what we've done, right? Like we've gone all the way from high level customer complaint a request is slow to being able to understand and figure out what happened. Okay, so that's interesting. So there's a small spike here, but not a very big one. Let's try mutex count instead. Let's see whether it was just a high number of requests to this as opposed to each individual request blocking for longer. Setting alerts for muddled anomalies. If someone wants to bring up Chuck's question.
Yep.
So I'll talk about that in a second, about how we kind of look for anomalous behavior inside of our production environments. The short answer is we don't necessarily alert on individual anomalies because there are always going to be small anomalies that are happening that may not necessarily be user impacting.
Makes sense. Yep.
So yeah, actually, let's go ahead and do that really quick. So for instance, that query that I ran that took forever, that should turn up inside of one of our service level objectives. So I'm betting that we'll see a pattern where every 15 minutes things get a little slow and violate some of our service level objectives. So this is what we think about when we think about detecting anomalies in behavior, is we tend to think about, oh, hey, look at that. Yep, that's 15 minutes ago. That's going to be an hour before that, cool. An hour before that, an hour before that, right? Like, so, right. So we look for a anomalously high rate of errors or slowness, higher than we're expecting. So we expect 99.5% of the time, when you come to Honeycomb and you run a query, it should take less than 10 seconds. And for the queries where that expectation is violated, we do have analytics that tell us what went wrong. For instance, that 3% of our failures are from aborting due to out of memory. Or we can see that one particular team ID is contributing the majority of these failures, right? So that's the kind of thing that we think about often. Okay, I know which team ID that one is, right? Like, so that's the kind of thing that we think about in terms of being able to figure out what's going on, right? Like, first of all, is it user impacting? If not, ignore it for now. If it is user impacting, make it faster for a human being to drill down to figure out what's happening and why. one particular developer causes most failures. Yeah, there may be some people at this particular client who love bringing up the 60-day view and refreshing it a lot, and it turns out that generates a lot of load on our systems. Let's see whether this product is behaving better now. Okay, good. It's loading again. So let's see. Behavior over past hour. I'm looking for something at 15 past. Oh, yep, that is a high number of contended locks that happened there. Let's zoom in on that and ask it what's going on there. Oh, that's just H2E2, so that's not the problem. Let's go back to 3 hours. And let's also put in get dataset version. That's really interesting that get dataset version is not, despite being the source of, according to that tracing, being a source of a lot of the pain, it's not represented in this flame graph at all. So, interesting mysteries for me to look at after the stream. But this is basically what I do every day at Honeycomb. Is I get to play around with user data to figure out how we make Honeycomb faster for our customers using Honeycomb. But kind of exemplifying what we've seen so far, right? Like I think the really cool thing is that ability to do high cardinality analysis, that ability to hone in on what one particular customer is doing, or to group behavior by individual tenant ID or user ID, or kind of combinations of those things. That's what makes things really, really powerful and makes it possible to diagnose anything with Honeycomb. So to show you one thing that's kind of slightly more AWS related, I want to share with you a cool comparison of what it looks like for us to evaluate migrations in AWS. So this is a migration that we just finished, migrating onto running all of our Lambdas on ARM64. So the Honeycomb query backend is built on, at least for data that's older than an hour or so, is based on AWS Lambda. So you can see here that a month ago,
Before the migration?
Before we finished the migration, okay. We were basically running 2/3 ARM, 1/3 x86. So you can see over here, right, like basically a 3-to-1 ratio, 2-to-1 ratio, something like that. Mm-hmm. And over here you can see we've migrated to 99% ARM. 1% is just held back in case we need the capacity on x86. But the cool thing is that you can see that, yep, the latency actually looks very, very comparable. That we're able to also, if I group this by...
So just to be clear, Liz, so this migration is all about like moving off like from x86 to ARM processors, right? Okay.
Yep.
Okay, good.
Yep. Migrating off x86 to ARM. We've already moved all of our EC2 instances. This is just about kind of attacking the AWS Lambda usage. Mm-hmm. And the cool thing here is you can see that we are using 20% less CPU and 20% less RAM with ARM. Wow. And we're getting, comparable, so maybe cool. Slightly higher latencies. But because ARM we're able to run 20% less cores, and each core second costs 20% less. This is a major net cost savings for us.
And if I understood correctly, what you're showing it right here, you are literally using the observer to observe the observer, right? Like
yep.
You're using Honeycomb.
That is correct. And this is turtles all the way down. So I can go over here, and I can come over here and ask what's the performance of dog food using our kibble environment. So
nice.
Yep. So you can see here that we we use dog food. Here's the performance of dog food over time, but wait, there's more. I can actually go and examine the performance of kibble over time because that loops back around to production. So yep, turtles all the way down. Is there a tool that shows how much you're preventing global warming by migrating to ARM? So this is feedback that I actually have for the AWS team, in that the AWS Carbon Explorer actually shows 0 if AWS has paid for carbon offsets for your compute. So ever since January of this year, all of our numbers report 0 because it's all been offset. So it's actually hard for me to know how much less in carbon credits AWS had to buy to keep us carbon neutral. I would like to know, right? Like, yep. But certainly based off of what we've seen about power efficiency numbers, I think the published number says that that Graviton is 1.75 times more carbon efficient than x86. So extrapolating based off of that, yeah, it's basically roughly you're roughly cutting your carbon emissions by 40% if you move to Graviton.
That's pretty cool.
Yeah,
we're
people
just
haven't
coming
seen the
up on
Carbon
time.
Explorer. Let me see. I'm actually going to need to briefly pause my screen share in order to pull this up. I want to make sure I don't accidentally flash the total volume over AWS bill or anything else that my company might consider sensitive.
Yeah, no problem.
But yeah, if you search the customer carbon footprint tool inside of inside of AWS, you can see what I mean. Okay, I think this should be safe to show you. Go ahead and pull that back up on screen.
All right.
So yeah, basically you can see over here, usage increased. Granted, it increased at a slower curve than it otherwise would have had we not migrated most of our stuff to Graviton in, by mid 2021. But you'll see January 22, it basically drops to 0, right? And it's like, I want to see, I want to see how much of an impact I'm having on total power consumed, but I can't. It's a little infuriating, but that's okay. The point is that this has benefits for the Earth. This has benefits for us as well, as far as running kind of one of the most energy efficient observability tools out there that kind of can do all of these generic queries on the fly.
Yep. No.
So I just had like 2 last questions. So the first one was, is there any links that you wanted us to share in chat for the viewers?
Yes.
Yep.
So the main one that I would say is if you want to share with viewers the link to try Honeycomb for yourself. So if you go to honeycomb.io/sandbox, I'll paste that in the chat here. That will let you try out kind of debugging, not the same Fibonacci app, but kind of the microservices demo, right? Like you're working like a shoe store or something, right? Like, and seeing the performance degrade and being able to debug the performance anomaly. That's something that you can do. And also, if you hit that button in the upper right-hand corner of honeycomb.io to get started, we would love to have you try out the Honeycomb product. And by the way, it's free up to 20 million trace spans per month. So, go nuts, have fun using Honeycomb, and we're not going to charge you for it, assuming that you're sending us a relatively small amount of traces to start.
Yep. No, I think that's more than enough, like for people to do the experimentation and the platform. And
experimentation, the number one thing that I recommend people do with their free quota, set up traces on your continuous build system.
Yes.
So actually, let me show you that really quick, because I think that's a lot of fun. So let's see. What do we call this? So I can actually get a graph of how long have we taken to do builds over the past 60 days. And I can see for each of these main branch builds, what was the slowest step. So I can actually get a trace visualized per build that shows me each component of the build, where it got slow, where it got stuck, which I think is really, really powerful. Let me actually, since I'm only actually interested in the past 8 hours, let's make that go a lot faster. There we go. So I can look at the build that I ran this morning, or one of the builds that I might have run. Wonder why this is being slower than I would like. There we go. So we can see it ran slightly over 10 minutes, and we can see each of the steps in it. And we can see overall, basically, that building Docker images, that's the slowest part of our build. But generally speaking, this is kind of fast and performant enough to keep us on less than 15-minute builds, and that's kind of what our standard is. So relatively small in terms of cost, because it's like, maybe you're sending, 10 spans or even maybe 100 spans per build, but like builds are relatively infrequent, and yet they're, the XKCD comic of, why are you fighting with foam swords? Oh, code's compiling, carry on, right? Like, the more you can reduce that time, the better it is for everyone involved.
Awesome. And I just had one final question for you before we kind of wrap up for the day. As I guess, and it's a bit less like technical and more about you, as a recognized industry expert in this area, what would be one of the most challenging lessons that you've learned and that you'd like to share with our viewers?
I think the main thing that I've learned is don't be afraid of failure. Failure is a learning opportunity. So if you're afraid of breaking your systems, don't be afraid of them. Like, break your systems as long as you learn from it so that you don't break them the same way twice.
I love that. That's
Yeah,
fantastic.
that's so cool. Yeah. Especially
Yeah.
the part for learning from it. Like, it's not break for the sake of breaking, right? Which is cool, but you also have to be responsible.
Exactly.
Yes. Nice. Liz, I can't express how much happy I had. I was here like listen to everything that you were showing, because to wrap up what Liz did, I mean, not sure if you got this impression, she compiled everything that we have heard so far about all the technologies regarding observability. And she made it through in a compelling story and narrative where she started with the suspicious of a problem in a system, and then she started diagnosing the problem, and then going back and forth to, slice and dice into the Honeycomb observability platform and finding more assumptions and going back to more instrumentation and going back. And she literally showed to you how observability needs to be implemented. So she did a great job. And that's the best demo that we could ever bring it to you right here about how observability needs to be implemented. So, and arguably from someone that knows what she does, right?
Yeah, this has been really wonderful.
I hope I
Thank
know
you
what
so
I'm
much
doing
for
at
joining.
least.
Okay, all right.
Yeah, thank you so much for joining us today. We're getting some claps in the chat already.
Yes,
and
claps for Liz, please.
Yeah, thank you. It's been lovely having you on the show today.
Awesome. Thank you very much.
Hey there! Thanks for checking out this video. Remember to give it a like and share with your community. Then hit subscribe and the bell for all the latest content that will help you build on AWS.